So it's my pleasure to invite Graham Barrett from Australia to talk to us about the free lunch, which is Ray 1 EMV.
My talk today is going to be on extending depth of focus, and I raise the question, should this be positive or negative, talking about some of the optics. And people often ask me, what made me choose spherical aberration as my first choice for extending the depth of focus? Now, there's several reasons, and the first one is the initial concept was, what is perfect vision? Perfect vision really is a balance of good resolution, but also adequate depth of focus. And when I looked at the optics and what you could do with optics, I felt that positive spherical aberration was the best principle to achieve the same. There's certainly unique features about positive spherical aberration. If you have some defocus due to myopia and you have some defocus due to spherical aberration, you put them together, there's a synergy, and the combined wavefront is actually better than either with myopic defocus or spherical aberration alone. Also, and this is often not well understood, all lenses are decentered to some extent. We actually don't know where we should actually put them. And if you look on the right, or actually on my left, looking at the screen, with the positive spherical aberration, with decentration, there's very little impact. The MTF is not altered. If you look at negative spherical aberration in contrast, even a small amount of decentration will drop the MTF significantly. So based on these principles, and it's not just simply adding positive spherical aberration, it's a sophisticated optic. It's a combination of fourth and sixth order aberrations combined over different optical powers, so the same effect is found across the entire range. And having this continuous curvature, but the amount of spherical aberration tapers off towards the periphery to maintain contrast with larger pupils in low light conditions. But using this principle, you can make a lens which gives you a tangible benefit, still falling within the ISO and ANSI standards for a high-quality monofocal lens. As Ron is alluding to, trying to get what you're having now, which is a free lunch in optics. So this is looking at the area under the curve, and you see for the simulated visual acuity for Array 1 EMV at 0.2 logmar, that's 6.9, there's really a good extended depth of focus, right up to minus 2.5 diopters. You can compare that to another so-called extended depth of focus lens, like the Pure C, which doesn't have a continuous curve. It has an annular ridge of increased power within the pupil zone. And you see it looks very similar. So this shows you that the terminology of enhanced monofocal and extended depth of focus is not really a proper distinction, because here you can see that the simulated intermediate and near is equal to what is so-called monofocal plus lens to a so-called extended depth of focus lens. Look at the MTF. You can see Vivity there, which is almost a 50% reduction in MTF. Some of the MTF is only distributed in one direction than the other. You can tell a lot about how a lens will perform clinically by looking at the MTF. One thing you can do, if you look at this paper by Gerd Arfath, is do a resolution target and simulate directly, looking at the resolution target, the impact of that particular extended depth of focus lens. One thing is quite clear when you look at that comparison in Gerd's paper, that in order to get reasonable reading vision with all these extended depth of focus lens, you need to add some myopic defocus in one eye, if you look at the binocular defocus curve. And this is where the EMV is designed for exactly that. It's the right type of extended depth of focus to combine with myopic defocus. And if you're serious about providing near vision with extended focus lens, you should use some extent of modest monovision. If I did anything worthwhile, it's identifying an amount of myopic defocus, which I call the magic number, which is optimum. Because at -1.25 myopic defocus in one eye, you avoid asthenopia, it preserves contrast and stereoacuity, as opposed to what was often practiced, which was traditional monovision at -2. But what does the EMV add to the use with modest monovision? And I think it is fulfilling the promise that the patient expects of getting spectacle independence. If you target emetropia, you get more near and intermediate. But also, if you use some degree of myopia in one eye, there's less adverse impact on the distance vision in that myopic eye. Also, if you do a modest amount of monovision or minor amount, -3/4, you get more near than you would get with traditional monovision. And also, if you do use more monovision, say -1, -1.25, there's less impact on the distance vision in that myopic eye. This is a defocus curve from Tung Kwan in Singapore, and he did a comparative study using EMV with emetropia and using EMV with monovision. If you look at the binocular defocus curve for the emetropic eye, you can see even down to 40 centimeters, you can maintain 6/9 acuity. So it's a good defocus curve. But if you look at those patients who had modest monovision and look at their defocus curve, it's even broader. So the drop-off is much more, is further down the track, and you can expect good vision 6/6 for distance, 6/7.5 for intermediate, and 6/9 for near. So the blue line is the eyes, the binocular defocus curve for those with monovision. The red is the ones for emetropia. So even the emetropic eyes have a very good defocus curve. They are getting some useful near vision, good intermediate, but you can see how much more near vision adding that modest monovision with the EMV provides. This is not only for photopic, as you see on the one side of the chart, but even in mesopic conditions. They also did a questionnaire, a CAT-QUEST-9 questionnaire, and this shows that over 90% of patients in their questionnaire were able to read both small print for labels and also subtitles without glasses. So very good unaided vision. And even when it comes to reading on labels, it's 100% with modest monovision and EMV. It's still pretty good for emetropia in both eyes, 67%.